Well, I just want to put a bow on this percentile rank business, and this will do for Chapter 2. I want to read the definition. The rank or percentile rank of a score is defined as the percentage of individuals in the distribution with scores at or below that value. So as I look at this normal curve, below is to the left. So everything at or below 130 is roughly 98th percentile. And of course, on the other end, everything at or below 70 is only about the second. Now, you're not expected to know that. You can't really tell by looking. But nonetheless, that's what it means. If I could, I want to go to this very crudely drawn graph, and it's mildly embarrassing, but there are 20 boxes here. 1, 2, and here's another 4, 6, 1, 2, 3, 4, 14, 19, 20. So if I ask myself, what value is at the 95th percentile? It's 4.5. If you look at 4.5 where the dotted red line is, there are 19 out of 20 boxes that are to the left and below, and only one box that's to the right and higher. And so what's 19 over 20? 95% or 0.95. And I could ascertain that from the table too, 0.95 or 95%. Now here, to the casual observer that doesn't know about upper and lower real limits like we do, they would say 4. But we know it's 4.5 because we're incorporating upper real limits. Let's take 3.5. Here's 3.5, and I don't have a red line by that. I'm moving my cursor where 3.5 is, and I know it's crudely drawn, but there are 14 boxes, if you will, to the left and lower than 3.5, and then 6 to the right and higher. 14 over 20 is the 70th percentile. Now, here's a kind of a crazy question, and you can do this in your head. Maybe I'll ask an extra credit question about it. Interpolation. If I looked and I saw that a score of 1.5, and again, we're using upper real limits, is at the 10th percentile, and a score of 2.5 is at the 30th, crazy question. What score would be at the 20th percentile? 1.5's at the 10th, 2.5's at the 30th. How would I ever go about answering that question? There's a formal process called interpolation, but just reason through it in your head. Isn't 20 halfway between 10 and 30? Of course it is. And then it begs the question of what's halfway between 1.5 and 2.5? What is halfway between 1.5 and 2.5? Isn't it 2? And let's take a look. If I went to a value of 2 and split this column right here, I'd have a whole box, a half, a half, a half, a half, because I'm splitting the column where 2 is. A whole plus a half plus a half plus a half plus a half. And what is 2 wholes plus 4 halves? Isn't that 4? Sure. And what's 4 over 20 if I'm considering the scores that are less than or equal to 2.0 right in the middle? Of course, 4 over 20 is the 20th percentile. And so I could just reason my way through it in an easy one like that. Take another one if you'll indulge me. What score would be, say, at the 50th percentile? I see that 2.5 is at the 30th. 3.5 is at the 70th percentile, and I can confirm that with these crude-looking boxes. 3.5 at the 70th percentile. 2.5 at the 30th. Is there something that would be exactly at the 50th percentile? Sure. And with 20 boxes, that'd be 10 boxes. So what's halfway between 30 and 70 is 50. What's halfway between 2.5 and 3.5? Isn't it 3.0? Sure. And if I put 3.0 right here, if I drew a line, I'd have 6 whole boxes and 8 half boxes. 6 whole boxes, 8 half boxes, and of course 6 wholes plus 8 halves is 10. And in that case, of course, 3.0 would be the exact bifurcating mark of this graph, the 50th percentile. So just a little reasoning there. I don't think I'll go that far on your test, but I just want to make sure that you could reason your way through this idea of percentiles.